this video, we will be discussing about minimum cost for tickets. You have planned some train traveling 1 year in advance. The days of the year in which you will travel are given as an integer array days. Each day is an integer from 1 to 365. Train tickets are sold in three different ways. A 1 day pass is sold for cost $0, a 7 day pass is sold for cost $1, and a 30-day pass is sold for cost $2. The passes allow that many days of consecutive travel. Return the minimum number of dollars you need to travel every day in the given list of days. So, what they are saying is that in the input, we are given an integer array days and we are given another array costs. These days are the days in a year. So, the values in this array will be from 1 to 365, and these are the cost of the passes. So, basically, the question says is that you have planned some train traveling 1 year in advance, right? And these are the days on which you need to travel, right? For traveling, you will have to buy a pass, the train ticket, right? So now what does this array represent? So if you buy a 1 day pass, then its cost is $2. If you buy a 7 day pass, then its cost is $7. And if you buy a 30-day pass, then its cost is $15, right? So if I need to travel at day one, I am having these three choices. So if I buy a 1 day pass for $2, then I will be able to travel for 1 day, which is the current day, day one, right? So next I need to travel on day four. So for day four, I will have to buy another pass, right? So if let's suppose on day four, I buy a 7 day pass for $7, then I can travel for 7 days with this pass. So if I bought it on day four, so day 4, 5, 6, 7, 8, 9, 10, right? These are the 7 days, right? For these 7 days, I can travel with this pass, right? So we need to identify that what is the minimum number of dollars that we need to travel for each of these days, right? So how to solve this? So see, starting from day one, right? We will start from day one. Now at day one, I am having three choices that either I buy a 1 day pass or I buy a 7 day pass or I buy a 30-day pass, right? So I am having three choices. If I buy a 1 day pass, it will be $2. If I buy a 7 day pass, it will be $7. And if I buy a 30-day pass, it will be $15, right? So if I bought a pass for 1 day, then what will be the next day two, right? Because on day one, I will be able to travel with this particular pass. But on day two, I will have to buy a new pass, right? But you will see the day two is not present in the days array. On day two, we do not need to travel, right? So what is the next day? Next day is 3 again. 3 is not there in this array, so then that means on day 3 we need not to travel. Then we have day 4. Day 4 is there, so on day 4 we need to travel, right? So if on day 1 I bought a 1 day pass, so the next day that I have to travel is day 4, right? Then if on day 1 I bought a pass of 7 days, then from day 1 till day 7, I have this particular pass, and then the next day will be 8, where I will have to buy a new pass. And 8 is present here also. So the next day here is going to be 8. Then here on day 1, if I buy a 30-day pass, then for day 1 to day 30, I am having a pass, right? And the next day would be 31. But the days are only till 20, right? So then that means this is the end, right? If I buy a 30-day pass for $15, I will be able to travel for all these days, right? But we need to identify the minimum dollars needed, right? This $15 might be the minimum or might not be the minimum, right? So we will have to check for others as well. Now here at day 1, when I bought a 1 day pass, so I came at day 4. Now at this day 4, again I am having three choices that I buy a 1 day pass for $2, a 7 day pass for $7, or a 30-day pass for $15, right? So if I buy on day 4 a 1 day pass, then the next day would be 6, right? If I buy a 7 day pass, then from 4, 4 plus 7, that will give you 11. So till day 11, I am having a pass. So my next day would be 20. So we'll have a 20 here. And then on day 4, if I buy a $15 pass, then from day 4 till 30 days, that is 34 days, I will be able to travel with this pass. So this is the end, right? And then here again you will have three choices, and here also again you will have three choices in the same way, right? Then if we see for this day 8, again we are having three choices. I took a $2 pass, $7 pass, $15 pass, right? So on day 8, if I take 1 day pass, then the next day would be 20, right? So we will have a 20 here. If on day 8, I buy a 7 day pass, so it will be 8 plus 7, that is 15, right? So the next day would be again 20, right? Then if on day 8, I buy a $15 pass which is for 30 days, so it will be 8 plus 30, that is 38, right? So we will be able to travel for all the days. So this is also the end, right? Then here again for this 20 we are having three choices: a $2 pass, a $7 pass, or a $15 pass. In all of these cases we will travel for all the days, right? So for this 20, whatever will be the minimum of these three, that will be returned, right? The minimum is, see, 2, 7, 15. The minimum is 2, right? So this will return 2, right? Similarly, for this 20 also, you will have three choices and it will return 2, which is the minimum, right? So this will return 2. So at this particular point, $4 you had to spend. Here 7 plus 2, $9, and here $15, right? So 4, 9, and 15. Minimum is 4. So from here, 4 will be returned, right? And then for this one, here it costed $15. Here it is costing 7 plus 4, that is $11. And here also something will be returned, right? So from left something will be returned, from the middle it is getting 11, and then 15, right? So this will be, I think, less or equals to 11 only. But out of all these three, when you will draw the entire tree, you will get that the minimum cost that you will get is 11. So 11 is the minimum dollars that you need to require, right? So if you notice over here that for each day we are having three choices of these passes, right? So we can apply recursion over here, right? For each of the days. So we will always start from the day 1, right? And max till when can we go? We will go to the maximum day in our days array, right? Till 20. So basically this recursion will happen from 1 to the max day that we have in the days, right? And the upper limit of this max day is 365, right? So this can be the depth of our recursion tree, right? And at each point we are having three choices, right? And how are you going to identify that what is the next day, right? So if you see at day 1, right, we know that if we buy a $7 pass, then it will be 7 days. So 1 plus 7, that is 8. 8 is the next day. But you will first have to check, do I need to travel on day 8 or not? So you will come to this array and check, is 8 present in the array or not? You will see that yes, it is present. So we will go for 8. If it is not present, then we will check for 9, then 10, then 11, and so on till the max day, right? So if we will simply go and find out in this days array, then it will increase our time complexity, right? Because at each of these points, we will find whether the next day is present here or not, right? So to find it efficiently, what we can do is that we can put all of these days inside a set or a map, an unordered set or an unordered map, right? So that we can efficiently identify whether a particular day is reserved for traveling or not, right? Here, if we directly try to find out, then it will be order of n. But if we will try to find out in a set or a map, then it will be more efficient, right? So here you will see that on day 1, I bought a 1 day pass. So my next day will be 2. So you will check, is 2 present in my set or not? If it is not, then I will move to the next day, that is 3. If 3 is also not present, then I will move to the next day, which is 4. 4 is present. So for 4, I will make 3 choices of buying these passes, right? So this is how we can solve this. So now here, as I told you, the depth of this tree is going to be equals to the max day that we have in the days array, right? And for each point, we are having 3 choices, right? So the time complexity of this will be somewhere around 3 to the power max days, right? This is very large. So if you closely look over here, again, we are having sub problems to solve. So see, here also, I was at day 20 and I wanted to identify that what is the minimum cost required for me to travel for this 20 day and the coming days, right? Here also I needed to identify the same thing. Here also I wanted to identify the same thing, right? So again, here we can apply memoization and cache our results so that we can improve our time complexity, right? So here the only thing that is changing is the current day, right? Rest everything is as is. This cost we will be identifying basically in the DP vector. So for memoization, we will use DP vector, right? So in the DP vector, the value will tell you the cost, right? So the only other thing that is changing is the current day, right? So we would be needing only a 1D DP, right? A 1D DP. And what will be its size? Since its indices will be storing the days, so the days will be from 1 till the max day that we have. So its size will be max day in the days plus 1, or we can say the last day, right? So this will be the size, right? So this is how we can solve this problem. Now there are other solutions also for solving this, that instead of taking the days from 1 till the last or the max day, you can keep a variable in the days vector itself, an index I, right? And then with that, for each point you can identify that what should be my next day by iterating in this days, right? So there are multiple ways of solving this. So this is one of the ways that I will be covering here. So let's just look at the code for this. So first of all, let us identify that what will be the last day. So it will be days dot size minus 1, right? The days are sorted in increasing order. So that is why we are picking the last value that we have in the days, right? Then we will also need to create a set, right? As I told you, for efficiently identifying whether a particular day has to be traveled or not, we will take an unordered set, right? So let's take it globally so that we don't have to pass it. So we'll take an unordered set. It will keep integers and let's name it the travel days, right? Then here in the travel days, we will push all the days on which we need to travel, right? So for int day, in days, what we will do in the travel days, we will insert this day, right? And then we can create a helper function which will return us the minimum dollars required. And in this helper function, we will pass the days vector, the costs vector, right? And the current day. So as I said, we will always start with the first day. So I will pass a 1 over here, right? Then here we will create our helper function which will return us an integer, right? It will receive the vector days, right? Then it is going to receive the vector which is costs, and then it is going to receive the current day which I am denoting with cur, right? Now what is the base case over here? So as I said that whenever our day was becoming greater than the last day that you have in your travel days, then we can say that we need to stop, right? So if at any point my current day becomes greater than days dot size minus 1, then in that case I will return a 0, right? Because we have crossed the days that were given to us, right? We could also pass this last inside our helper function, so we could use that directly, but anything we can do. Then here what we'll do, we'll check that is this current day whatever we have, do we need to travel on this day or not, right? So in travel days, we will find whether this current day is present or not. So if it is not present, then it will be equals to travel days dot end. When it is not present, so then that means we do not need to travel on this day, right? So we will just call the helper function. We will return from here itself. Days will be passed as is, costs will be passed as is, and we will move on to the next day, current plus 1, right? Otherwise, if it is present in the travel days, then that means we need to travel on this day. So let's find out what is the minimum dollars required, right? So if I take a 1 day pass, right, then my cost will be costs of 0 plus I'll call our recursion, which is the helper function. We will pass the days, the costs, and what will be the day? It will be current plus 1, right? Then if I take a 7 day pass, then my cost will be costs of 1. And inside this, I will add whatever helper returns me. I'll pass days, costs, and the day will be current plus 7, right? And if I take a 30 day pass, then I will take costs of 2 plus helper, days, costs, comma, current plus 30. right? So in these three variables, I will get that what is the cost required if I take 1 day pass, if I take 7 day pass, or if I take a 30-day pass. And which am I going to consider? I am going to consider whatever is the minimum of these three. So I will take the minimum of 1 day, comma, minimum of 7 day, comma, 30 day. I think I misspelled it, 30 day, right? So this is what we will return. And as I saw that we were solving sub problems over here, so we will also apply memoization. For memoization, we will create a DP vector over here. And as I said, it will be a 1D DP and the size will be equals to the max day plus 1. So we will create a vector int. We'll name it DP. Its size will be last day plus 1. All the values will be minus 1 initially. And then here in the helper function, we will pass this DP vector. Here we will receive this DP vector, right? And then whenever we are calling our recursion, we will pass this DP vector, right? Now here, we can check that if at any point the current day in DP is not equals to minus 1, then return it from here itself, right? And then here before returning, we will update it in our DP vector, right? So this is what our code looks like. So now if you see, we have taken a DP, right? Whose size is equals to last day plus 1, right? And then here we are filling the DP in the helper function, and for each of them we are applying three operations, right? So we can say that the time complexity of this code will be order of whatever is the max day in the array that is given to us. And the space complexity will also be equals to whatever is the max day that we have, because we have taken this DP vector, right? And our recursion tree depth will also be equals to the max day that we have, right? So let's try to run this code. So here we forgot to pass our DP vector. Let's run it again. So the test cases are accepted. Let's try to see if it gets submitted. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.